So we're going to go over some of the questions on the lesson sheet for lesson 6, and you can see that this is question 2 on the lesson sheet. It says a sample space contains 7 sample points, 1, 2, 3, all the way up through 7, and events F and G and H as shown in the Venn diagram. The probabilities of the sample points are, and there's probability of 1 is 0.2, and then probability of 2 is 0.1, and you can see them all. And this says, the first question says, what is the probability of the complement of G? Well, we know that the complement of G means everything that's not in G. Well, what is in G? Well, here's G, and it includes 3, 4, and 5. So everything not in G is 1, 2, 6, and 7. So really we just need to add up the probabilities of 1, 2, 6, and 7. And that's 0.2 for 1, that's 0.1 for 2, 0.15 for 6, and 0.1 for 7. So 0.2 plus 0.1, that's 0.3, plus another 0.1, that's 0.4, plus 0.15, that's 0.55. And so the probability of the complement of G is 0.55. Now we want, what is the probability of G given H? This is a conditional probability. So we first need to find out what is the probability of H. Probability of H has to go on the bottom, and then in the numerator has to be the probabilities of everything that's in G that is also in H. Well, the only thing in H that's also in G is 5. And so the numerator here is just going to be the probability of 5 over the probability of H. Well, the probability of H is going to include everything in H, which is 6, 7, and 5. So probability of H is going to be 5, 6, and 7. So that's 0.25 plus 0.15, that's 0.4, plus 0.1, that's 0.5. So the probability of H is 0.5, and the probability of 5 is just 0.25. So it's 0.25 divided by 0.5. We can do that in a calculator. 0.25 divided by 0.5 is 0.5. It's 1/2. Yeah, that makes sense, because this is like saying 0.50, and 25 over 50 is 1/2. So the answer to this is 0.5. Now this one says, what's the probability of F given not G? Okay, so the denominator here is going to be the probability of not G, the complement of G here. A little ugly. There we go. Probability of the complement of G is going to go in the denominator. And the numerator is going to be everything, the probabilities of everything in F that are also not in G. Well, that means not 4, not 3, and not 5. So F contains 1 and 2, and those are not in G. F contains 3, but 3 is in G, so we're going to leave 3 out. Okay, we just want the probabilities of 1 and 2. So we're going to have the probability of 1 plus the probability of 2, because those are all the things that are in F but not in G. So that's going to be probability of 1 is 0.2, probability of 2 is 0.1, so 0.2 plus 0.1, that's 0.3. So this is going to equal 0.3 over, well, now we got to find the probability of not G. Well, the probability of G includes 4, 3, and 5. So not G, oh, we already did that all the way over here. Look, there's the probability of not G. Question 1 is 0.55. So we're going to put a 0.55 here. So we're going to do 0.3 divided by 0.55. 0.3 divided by 0.55. And that gives us 0.545. 0.545. And that's question 2. All right, so now we have a college has classified all their students as either graduate or undergraduate, and as either living on campus or living off campus. The results are summarized in this joint probability table. Suppose one student is selected at random. And so this one right here, do you see this right here? This 0.45 is the probability that we'll select a student that is an undergraduate student and they live on campus. This one is the probability of an undergraduate student who lives off campus. This one is the probability of a graduate student that lives on campus, and this one is the probability of a graduate student that lives off campus. If you were to add up all four of these, they would equal 1, because a student is either undergraduate or graduate. It's not both of them, and they're either living on campus or off campus. So these are all exclusive, these are all mutually exclusive categories, okay? So this first part is saying if the student is undergraduate, so given that the student is undergraduate. So we're not even going to consider the graduate students at all. We're only considering the undergraduate students. Just ignore the graduate students completely altogether. If the student is already an undergraduate, what is the probability that they live off campus? So this is the probability that they live off campus given that they are undergraduate, okay? So this is going to be the probability. So the probability of undergraduate is going to be in the denominator, and the numerator is going to be the probability that they're off campus and undergraduate, okay? And so the probability that they're off campus and undergraduate is right here. That's 0.32. And the probability that they're an undergraduate is the combination of both categories that have undergraduate. So 0.45 plus 0.32, that's 0.77. So let me erase this here. All right. 0.77. And so, again, let me clarify that the way we're going to do this is assuming they're already an undergraduate. So we're going to put the probability of undergraduate, and the probability of undergraduate is the combination of both of these categories. Ignore, we're leaving out graduate completely. We're not even looking at it, okay? And then in the numerator, we want the undergraduates that are off campus, and that's right here, 0.32. So our answer is going to be whatever 0.32 divided by 0.77 is. So 0.32 divided by 0.77. And that's going to be 0.416. We're going to cut off right here, and that 5 is going to round this other 5 up to a 6. So the answer is going to be 0.416, okay? All right, now what if the student lives on campus? Assuming the student lives on campus. So we're going to completely ignore all of the off-campus. We're going to completely scratch out this entire category right here and only focus on the on-campus students. Because it says, if the student lives on campus. What is the probability that they are a graduate student? So this is going to say, well, what is the probability that they are a graduate student given that they live on campus? So given that they live on campus, so what's the probability that they're a graduate student given that they live on campus? And so what we're going to want here is we're going to want the probability of on campus in the denominator. Well, the probability of on campus is both of the categories added together. 0.45 plus 0.07, that's 0.52. And then we want the probability of graduate and on campus together. Well, here's graduate, here's on campus, and when you put them both together, you get 0.07. So it's going to be 0.07. So we're going to do 0.07 divided by 0.52, and that gives us 0.135. So this one's going to be 0.135, okay? And then the last question says, if the student is a graduate student, so assuming they're a graduate student, so here's the graduate student, so we're going to completely ignore the undergraduate student part. We're just scratching it out. We don't need undergraduate at all. We're only considering these categories where the student is a graduate student, because it says if the student is a graduate student, what is the probability that they live on campus? So that's very similar to what we just did, but instead of being the probability of graduate given on campus, now it's the probability of on campus given that it's a graduate student. So probability that that they live on campus, probability that they live on campus, okay, given that they're a graduate student. Given that they're a graduate student. So we're going to put the probability of graduate student in the denominator. Well, the probability of a graduate student is both of these put together, and that's 0.23. And then in the numerator is going to be the probability that they're both on campus and a graduate student, which we've seen before. That's right here, 0.07. And so 0.07 divided by 0.23. 0.07 divided by 0.23, and that gives us 0.304. So the answer to this one is 0.304. And that's question number 3. All right, this question number 4 is going to ask some interesting questions because it's asking OR questions. And those are interesting. Okay, they're asking, well, let's get to it in a minute. It says 100 people were surveyed. One question pertained to their nation of birth. And you can see over here, they're either they were born in the US, or they were not born in the US. And so you can see here, U and then U apostrophe or U prime, this means the complement of U. So we have United States and then the complement, born in the United States, and then the complement of those born in the United States, which is all the people born in other countries. The result of this question and their sex are given in the table to the right. If a person is selected at random from those surveyed, what's the probability that each of the following events? So what's the probability that the person is male or was born in the US? And what that means is this, is we have to go, so we have 4 categories. We have this one, this one, this one, and this one. And we have to ask, this category with the 32, that's female and born in the US. This one is female but not born in the US. This one is male and born in the US. And this one is male but not born in the US. Okay? And so what we're looking for here is we're looking for the probability that the person is male or was born in the US. And so here's what we're looking for. We want all of the males, and this category is male, and this category is male. And then we want all of the people born in the US. Well, this one was born in the US, and this one was born in the US. So look, we actually want 3 of the categories. We don't want this category at all. Why? Because this category is neither male nor born in the US. So here's what we can do. We can add this plus this plus this. So 32 are female born in the US, 23 are male born in the US, and 28 are male not born in the US. But they can be included because they're male. And then over the total number, so in the denominator we want to put the total, which is 100. And so that gives us 32 plus 23, that's 55. 55 plus 28 is 83. And so we have 83 out of 100, and 83 out of 100 is 0.83, okay? Now, there's a more precise way of doing this, and that's where basically what you're doing is you have to add together all the males, which is 51, and you add together all the people who were born in the US, which is 55, so 51 plus 55, and then you subtract away all the people that fit both categories, which is 23. And if you did that over 100, you would get, well, 51 plus 55 is 106, and 106 minus 23, again, is 83 over 100, and so it's 0.83, okay? All right, let's do this next question here. Let me erase all the notes I made on the table here. All right, so it says, what's the probability that the person is female or was not born in the U.S.? So they're either a female, okay, so here's female, well, 49 of them are female, 49, plus not born in the U.S., well, that's 45 of them. Look, the total is 45. 45. And then if we subtract away the people who are both female and not born in the U.S., we subtract 17 and do that over 100. Well, 49 plus 45, that's, well, let's do that in a calculator. 49 plus 45. And then we're going to subtract away 17, and that's 77. So what we have here is 77 over 100, and the answer is 0.77. Now we could do it the other way. We can identify each category as being either female or not born in the U.S. So let's look at this one. This category here, these 32, well, they're female. And so that's 32 plus this one right here. Well, that one's also female. So we'll include that one, 17 plus. Will we include this one, this 23? Nope. It's not female, it's male, and it's not born in the U.S. It's U.S. What about this category, this 28? It's male, so it's not female. But it is not born in the U.S., so it's going to be included. So plus 28. If we add these together, 32 plus 17, that's 49. 49 plus 28, that's 77. And so that's going to wind up being 0.77, just like this one right here, okay? All right, last one. The person is male or was not born in the U.S. This is the same idea. We can take all the male, which is 51, and all those not born in the U.S., not born in the U.S., which is 45. We can add those together, 51 plus 45, and then subtract away the ones that are both, which is 28. So minus 28. So 51 plus 45, that's 96. 96 minus 28. Let's see here, 96, 60, that's going to be 68. This is over 100, so it's going to be 68 over 100, and that's going to be 0.68, okay? And of course, the other way that we could do it is we could, just a second here, we could take everyone who's male or not born in the U.S. Okay, so male, this category is male, this category is male, this category is not born in the United States. This one is female, but born in the U.S., so we're going to leave this one out. So we just need these three categories. So it's going to be 23 plus 17, which is 40, plus 28, that makes 68 over 100. Where am I getting the 100 from? Right here, it's the total, okay? And that's going to be 0.68, okay? And that's question 4. All right, let's look at this one. This one's a little more complicated. It has more boxes. It says, they surveyed 273 people, and a bunch of data were obtained relating to their employment status, which is employed or not employed, and what kind of mobile phone they use. So some of them use an iPhone, some of them use an Android, and some people use other. What's other? Well, others like, maybe a Nokia or a BlackBerry, old school phones, or maybe newer phones that have customized operating systems. We want to answer a bunch of questions here. A, B, C, D, E, and F here, okay? Now notice the total is 273, and that's what we're told here, that they surveyed 273 people. So every single one of these probabilities is going to be over 273, okay? So let's look at this one right here. It says, what's the probability that a randomly selected person is employed? Okay, well, employed, how many employed people are there? 202. 202 out of the 273 were employed. This is not a conditional probability. This is a very straightforward, simple probability. So all we have to do here is the 202 employed people divided by the 273 total, and now we're going to go over and do 202 divided by 273, and that is 0.7399. This fourth 9 is going to move this 9 up to a 0, really a 10. The 9 becomes a 10, so the 3 becomes a 4. It's going to be 0.74. So this is going to be 0.74. All right, let's do B. B says, what's the probability that they are both employed and an iPhone user? Okay, it's not or, it's and. So it's just one box, the one that's employed and an iPhone user. Well, here's employed, here's iPhone user, and so this box right here is those people who are employed and they are an iPhone user. So that's an easy one too. It's 91 people out of 273. So we'll key that in. 91 out of 273. That's going to give us 0.333. All right, so 0.333. It's about a third of the people. About a third of the people are employed and an iPhone user. All right, let's go to part C. Part C says, what's the probability that they are employed given that they use an iPhone? So now first, it's only out of the people that use an iPhone. Here's the people that use an iPhone. We're ignoring all of the other people. So we're not even including the total. We're not even using the total. We're only including the 120 iPhone users, okay? And so it's going to be, so what we need in the denominator is the probability of an iPhone user, okay? Probability of iPhone. Well, let's find the probability of iPhone in order so that we can do this. Well, probability of using an iPhone is 120 people use an iPhone out of 273. So that's 120 out of 273. All right, 120 divided by 273. Now, be careful here. We can't round to 3 digits because we're about to put this number into a calculation. So we're going to go a couple more digits. We're going to do 0.43956. So 0.43956. That's what we're going to put in the denominator here. 0.43956. Let me make sure that's right. 0.43956. Yep. Now, in the numerator, we're going to put all of the people that are employed and using an iPhone. Okay? And we already saw that up here. That was 91. All the people employed using an iPhone is 91. And so that was 91 out of 273, so that's 0.333. So we're going to put 0.333, and really it's a couple more threes, 3, okay? And so this is going to be, let me rewrite this. It's the probability that a person is using an iPhone, or excuse me, employed, given that they use an iPhone. Let me show you how let me remind you how we would write that. We'd say the probability that they are employed given that they use an iPhone. Remember, we have that vertical bar. So probability that they're employed given that they use an iPhone. And so we put the probability of iPhone down here in the bottom, and then we put the probability of the people who are both employed and using an iPhone in the numerator, and then we calculate in the calculator. So we're going to do 0.33333 divided by 0.43956, and that gives us 0.758. So this one's going to be 0.75. All right, let's try part D now. Probability that they are an Android user given that they are employed. And so probability of Android, given that they are employed. So we want to put the probability that they're employed in the denominator, and we know that that's 0.74, so 0.74. And then in the numerator, we're going to put the probability that they are an Android user and they're employed. So Android user, employed, so right here, 86 out of 273. Well, let's find out what 86 out of 273 is. Okay, 86 out of 273, and that's going to be 0.315, and I want to put 018 there too, 315, 018. 0.315, 0.018. And now we're going to divide that by 0.74, 0.315, whoops, go back here, 0.018 divided by 0.74, and that gives us 0.4257. 4257. Now I want to show you something. There's actually another way of doing that problem and some of these other, the conditional probability problems, another way that you can do them goes like this. Basically, you can put the Android and employed in the numerator, 86, divided by the employed number, which is 202. And the reason for that is this, when you divide 86 by 273 and then divide 202 by 273, the 273 actually cancels. This is the same thing as 86 over 273 divided by 202 divided by 273. By algebra, these actually cancel. And so really, you can just do 86 over 202. And I'm gonna show that to you down with the. I'm going to show that to you down here with the with this one as well. Okay, so 86 divided by 202. If we do that in the calculator, 86 divided by 202. Oops. Hang on a second. 86 divided by 202. Sure enough, gives us basically the same thing, 4257, okay? 0.4257, 0.4257, okay? So let's look at this one down here, this 0.758. I can show you that it's going to work the same. It's a little faster. It's well, let's just get to it. So look, if we do all the employee and iPhone is 91, or employed and iPhone, divided by just iPhone, which is 120, so 91 over 120, is going to give us that same answer. 91 divided by 120 gives us that same 0.758, which is what we, 7583, which is what we had before, 0.7583, okay? All right, let's look at this part E here. Part E says probability not employed given they use a different phone type. So they're not employed, so probability that they are not employed given that they use an other phone type, okay? Now, if we use this method here, where we just do the numbers and leave out the 273, watch what it becomes. So other, the total on other is 44. So we'll put that on the bottom. And in the numerator, we're going to do the crossover of not employed and other. Not employed and other is 19, okay? And so 19 divided by 44, 19 divided by 44, and that gives us 0.4318 or 0.432. I'm going to put 0.4318, but you could also put 0.432, okay? All right, now let's talk about this last part. Are the events of employed and Android independent? All right, so for part F, we want to know if employed and Android are independent events. And here's how we're going to do it. Basically, we're going to identify the probability of employed, and we're going to determine whether that's equal to the probability of employed given Android, okay? So, if these two probabilities are equal, if they are equal, then these two things are independent. But if they are not equal, then they are dependent. Okay, so let's find out if they're equal or not equal. Well, we already did the probability of employed, and we said that that was 91, because employed over here, or I'm sorry, it's not 91, it's 202. 202 divided by 273. So 202 divided by 273. And if we can remember what that was, 202 divided by 273 is 0.74. So 0.74. Now we're going to find out what the probability of being employed given we're an Android user. And remember, one way we can do this is we can put the number of just Android, which is 109, in the denominator, 109, and then put employed and Android in the numerator. So employed and Android is here, 86. So we'll do 86 divided by 109. And this is 0.789. 0.789. Now these numbers are really close, but they are not equal, and therefore employed and Android are not independent. Okay, and that's how you determine whether two events are independent or dependent.